If you haven't done so yet, please pause the video and try to solve the question on your own before moving on. So in this question, we're dealing with a situation in which there is work being done in lifting the skier up the ski slope. And in that situation, the following equation holds true. We have the change in kinetic energy of the skier equaling the work done by gravity plus the work done by any applied force, A. Now, the preliminary information in the question notes that the skier is moving with a constant speed, and so that means that the initial and final kinetic energies are the same, which in other words means that the change in kinetic energy is actually going to be 0. The question also notes in the preliminaries that the applied force does 900 joules of work on the skier, so WA would be 900. And then if we subtract 900 from both sides, we can see that the work done by gravity in lifting the skier is negative 900 joules. Now, the reason that it's helpful to know the work done by gravity is if you consider in part A, the skier is being, again, pulled up the very same ramp. And since it's being pulled up the very same ramp, or ski slope, I should say, that means that it's reaching the same height as it did in the preliminary information. In other words, the work done by gravity in part A of the problem is still that negative 900 joules that we just calculated. Now, part A also notes that the skier is moving at a constant speed, so once again, the change in kinetic energy will be 0. And so with that change in kinetic energy, and with the same amount of work being done by gravity, we're going to be able to easily see that the work done by the applied force is once again 900 joules, just as it was in the preliminary part of the problem. And so this turns out to be the correct answer to part A. Now, for part B of the question, we know that we can calculate the rate that a force is doing work on an object, because that's the same thing as power. And we know that power is equal to the work done by that force divided by the change in time. Now, we've already figured out the work done by the applied force. It's that 900 joules. What's perhaps less obvious is the change in time. Now, the question notes the speed of 1 meter per second. Of course, we know that speed is equal to a distance divided by a time. And so we can actually rearrange this equation to see that time is distance divided by the speed. The distance was stated in the question as being 8 meters. And then the speed, of course, in part B is 1 meter per second. So the time interval that we need to use in calculating this power is going to just be 8 seconds. So we'll plug in 8 seconds for that time interval and 900 joules for that work. And we get approximately 1.1 times 10 to the power of 2 watts. So this would be the correct answer to part B. And for part C, it's virtually the same process, except now we're using the speed of 2 meters per second. So the time's going to change. We'll take the same distance of 8 meters and divide it by that speed of 2 meters per second. And of course, that's going to give us 4 seconds. So we'll go ahead and plug in the 4 seconds for the time interval. And when we do that, we get approximately 2.3 times 10 to the power of 2 watts. So that's the correct answer to part C. Thanks for taking the time to watch the video. If you liked it, please click the thumbs up icon and also subscribe to the channel. You can also send in your own question to this email address and I'll do my best to answer it on YouTube.